Good afternoon, class. This is a continuation of our last class where we were having the activity crushing as our subtopic in networking. And we wish to have a continuation from our example, which was December 2014, question number 3, part number C. We have done the networking, we have identified the critical activities, and now we were to look at the next step, which was to involve the crushing of the activities. So before we do the crushing of the activities, we need to know by how long should an activity be crushed. Our time was in weeks, so we want to know the crushable time for each and every activity. That is by taking the normal time minus the crush time. And we do this for all the activities, both the critical and also the non-critical activities, because along the way, we might find an uncritical activity emerging to be critical. So we are going to first of all compute the crushable times for all the activities. And here with me, I'll talk about the crushable time. Crushable time. And this is computed as the normal time. I'll use NT for normal time, and we minus the crush time, and I'll call it the CT in short. So we'll start with the activity. We mentioned the activity in the project. And we have said we are computing this for all the activities. So for activity A, our crushable time will be given by the normal time from the question is 5. This is 5 weeks. And we are going to subtract the 3 weeks given as our crush time. And we can be able to crush activity, let's say by 2 weeks. Then activity B, you'll see that the normal time is 4. The crush time is also 4, meaning at no point we can be able to crush the activity B. There's no time to crush it. Activity C has a normal time of 2, crush time of 1, possible to crush the activity by 1 week. Activity D, we have a normal time of 1, crush of 1, meaning again for activity D, we have got no time to which we can consider to crush the activity. Activity E, we have a normal time of 5, crush time of 3, and if we will consider to crush it at some point, we have got 2 weeks to guide us. Activity F, we have got 5 weeks as the normal time, crush of 4 weeks. And again, we have the crushable time of 1. Activity G, we have the normal time of 4 weeks, a crush of 2 weeks. And again, you can see we have got 2 weeks as our crushable time. Activity H, the last activity in the project, has a normal time of 3, a crush time of 2, and now the crushable time computed as 1 week. The next item that we should have before we start our crushing process is to have the computation of what we call the cost slope, or the incremental cost, let's say per the given form of duration. Like in our case, we're talking of per week. We can also call it the extra cost which will be incurred for every 1 week that you're going to reduce the time for a particular activity. In this case, our example, we are provided with the cost slope, and there it is called the extra cost per week for every activity in the project. However, if this was not provided, we should have considered to first of all compute the cost slope, which we normally compute as our handout, again, the one I had sent earlier, we clarified on this. The cost slope, we said it is supposed to be given by, we take the normal cost, the crush cost, we take the crush, this is supposed to be given by the crush cost, minus the normal cost we subtract the normal cost, and we are going to divide the whole of this by the so computed area, the crushable time. So you can bring your crushable time here, and you have to make sure that this is the correct crushable time for every activity in the project. And you have mentioned if the extra cost is already given, you don't have to go through this stage. You just use what you have been provided. The cost slope, if not given, compute it first. Now, in our project, we had already identified the various paths. So our process of crushing now begins. And I wish to do this in form of a table. Our process of crushing now begins. We'll have here the path. And as we write our paths, remember we do this in descending order, starting with the highest as we go down to the smallest in terms of the duration for each and every path in the project. So we'll start by highlighting our critical path, and our path was path B, F, H. Here we will indicate the duration of the path. And you remember that our time is actually coming in weeks. You can just indicate it there. So this was 12 weeks, the longest. Then we bring 11, where the corresponding path was path ACGH, with the project's duration being, or rather the duration of the path being 11 weeks. Then we had 2 paths sharing a period of 9 weeks. We can start with any. We have path D. Then we have G there with 9 weeks. And lastly, we have a path known as BE with the duration of the path being 9 weeks. Now, among the activities B, F, and also H from the question, which has the lowest incremental cost, or what we call the extra cost per week? We have activity F, activity H, and also activity B to guide us in our process of crushing the activities in the project. So we see from the question or from the data provided that activity F has an extra cost of shillings 700,000. Activity B, we didn't have the crushable time for it, meaning there'll be no additional cost since we are not going to crush the activity. And activity H has an amount of 1,000. So the first thing we are going to do, activity B, we have got no time to crush it, so we eliminate it in our process of crushing. We have got a crushable time of 0. Neither do we have the cost that is going to be an extra cost if we were to crush activity B. Then activity F and H are the points now left for our comparison. And we see activity F having a smaller amount, which is 7,000 compared with 1,000. So we go back to the crushable time and we ask ourselves, how long can we consider to crush activity F? The maximum amount, which is our crushable time, is only 1 week. So if we were to reduce activity F by 1 week, its duration, what would be the impact on the overall duration of the project, which is currently standing at 12 weeks? We'll see that it will go down by 1 week, and that would mean the amount of time for the project now would be 11. The question is, if we were to allow 12 to go down to 11, are we going to have 11 being overtaken by any other value as we look at the other parts? And we realize that our value going to 11 will still be the highest. Remember, one of the considerations during the crushing, you shouldn't allow at any point your original critical path be overtaken by any other path. Always maintain that path to be critical all the way until you are done with the process of crushing the activities in the project. So now it is possible for us to crush this activity F by this 1 week as the crushable time. And you realize that once we have crushed activity F by 1 week, then we have got no more time to crush activity F. So we can actually close that particular activity because no more crushing will be possible for this activity F to be crushed. So we have exhausted its crushable time. Let me make this one better. Here we had activity F and then activity H. So we are saying that activity F, we have exhausted it in terms of we can't crush it anymore. And we now revise the period of our project. And we do this to every path that is having activity F, it's going to be affected in that its duration is going to go down by 1 week. So what have we done? We have crushed We're saying we crush F by 1 week. Revising our paths, let's see. Because of F here, our period will now be standing at 11 weeks. No F, our path will still sustain 11 weeks. Again, the other two paths, they don't have an F. It means we are going to have the duration of the two paths at 9 weeks. Okay. Now, the only activity remaining to be crushed is activity here there was no H. It is activity H to guide us as we do the crushing. So activity H has a crushable amount of time of 1 week. The cost slope for that is 1,000 from the data given in the question. And if we were to reduce H by only 1 week, this period of 11 weeks will go down to 10. But you'll see that the variable 10 will be smaller by the variable 11, which corresponds to the next path. So when we crushed activity F, what happened? Two paths emerged to be critical. And now this is a point we consider to do the simultaneous crushing of more than one activity, but remember, should be in different paths. So we are going to crush activity H, that is a must. Activity H should be crushed with which other activity among activities A, C, and G. We go back to the data on the extra cost column. Among activities A, C, G, which has the smallest extra cost per week? Activity A has 200, activity C has an amount of 1,500, and activity G has an amount of 2,000. So we realize that activity A is the one that has the smallest extra cost. So we are going to consider now crushing. We crush activity activity H, which is a must to be crushed. And we also do together with activity A. Activity H to be crushed together with activity A here. So we are crushing this by how long? By 1 week. Now, activity A had a crushable time of 2 weeks. Why didn't I pick 2 weeks? Because the only amount available for us to crush activity H is only 1 week. So we cannot crush an activity beyond its crushable time. And remember, our original guide was by activity H. So as we crush it together with A, we cannot crush H beyond the 1 week, which is available crushable time. So by crushing activities A and H together, let's see the effect of this on our project. The path BFH, because of H, its duration will reduce by 1 week. We were at 11, now the period is at 10 weeks. Because of the A in our next path, the period has an amount of 11 weeks. It will go down by 1 week to stand at 10. The next two paths, they do not have H, and even activity A, so they'll still have a period of 9 weeks each. And therefore, because we have exhausted the crushable time of our original activity guiding us as H, we mark the end of the crushing of our activities in the project. So you realize that when we were crushing activity H and A, we didn't exhaust the crushable time for A. We still had a week remaining. But we have said we have marked the end of the crushing of the activities. It's because the guide was by the original critical activity, which in this case was H. So H was the dominating activity guiding us in the process of crushing. What if now, an imagination here, activity A had a crushable time of 1 and H had a crushable time of 2 weeks? What would we have considered to do? Would have crushed activity H and A together by only 1 week. Why? Because we could not have allowed activity A to be crushed beyond its crushable time. And then we do one more crushing of activity H, maybe together with any other activity, again by the 1 week that is remaining, because we must exhaust the crushable time for all the activities which were the original critical activities in the project. And the moment we exhaust those crushable time for all the critical activities, and I repeat, original critical activities, then we mark the end of the crushing of the activities. Our next item, now that we have crushed all the activities as per the requirements in this example, we now perform what we call the time cost analysis. What is the trade-off between the time and our cost? We do what we call time cost analysis. And here it is a question: did we crush this activity? Yes or no? By how long? What is the effect of that in our project? So here I'll talk about the crush, and this is where we'll be asking, was a crush performed or not? And here we'll talk of the duration of the project, our duration is still in weeks. And then here we talk about the cost of crushing. So we'll refer to it as additional cost. The additional cost of crushing. And then here we'll talk about, because in our example we had accommodated the overheads, then if we were to go down by every 1 week, there'll be some costs saved. So let's talk about those savings. And these are actually emanating from our overheads. Then here we talk about, finally, the total cost. All figures are in thousands of shillings, so I'll not involve those zeros in our workings. They are all uniform, so we'll just consider that we know this is the analysis we are doing, the time cost analysis. Okay, at the beginning there was no crash. The duration of the project was at 12. We had already computed the project's normal cost, which was associated with the 12 weeks period, and the cost was standing at an amount of 8,200,000. So we can just write 8,200 here. Figures we have said they are all in thousands of shillings. Okay, since there was no crash, meaning there was no additional cost, nothing that we were able to save, we performed the first crash guided by the previous table, and this was for activity F, and we reduced F by how long? By 1 week. And the duration for the project was now at 11 weeks. Because of crashing F, the cost will go up by 700,000 for that 1 week. Giving us an amount of 700. If there were 2 weeks, again, would have multiplied by 2, by 3, like that. Because of our project's duration going down by 1 week, we're able to save an amount of the overheads incurred by the project every 1 week. The overheads, we were told there were 400 administration overheads. So for that 1 week, we saved shillings 400,000 that 1 week. Again here, we have an amount of 400,000. Now we take away the overhead cost because we have saved that. The cost of crushing, we add it to the total cost. So we have 82, we are adding 700 minus 400. Our cost will now be at 8,500, or rather 8,500,000. Then we also did a crash of activity H together with activity A by 1 week. And for that 1 week, we crashed activity A and H together. Remember, they were done simultaneously. The project duration was now at 10 weeks. As a result of that, what will happen? Because of crashing activity H, let's start with H, there'll be some additional cost equivalent to how much? The additional cost of crashing activity H, we have an amount of 1,000. That is for 1 week. So multiply by 1 week. Giving us an amount of 1,000. And then we have activity A, whose cost is 200,000 per week. And it was just 1 week again, giving us an amount of 200, making a total of 1,200. You can see for that 1 week, we can only save 400,000 because these two were crushed together times 1 week. So we are saving an amount of 400. We revise our cost. What has happened? We were previously having the cost of the project at 8,500,000. We add 1,200,000, and we take away 400,000. This will lead us to an amount of 9,300,000 as our final cost for the project after the process of crushing is over. So if we are asked about the additional cost, you just come to the column called additional costs and you sum over all the costs involved when the crushing of the activities was actually done. If there's anything to be saved, again, you consider the column cost saved. You can also provide the total of that amount. But lastly, the comment you should be making is that finally, we have parts. We have parts B, F, H. And we also have path A, C, G being critical paths. These two are now actually critical. So in your comment, you can indicate that these are two critical paths. At the end, of the crushing of the activities. So we call them critical paths. And now the duration of the project at the end of the crushing, we see it at 10 weeks. So our exercise after this is what you'll do. I've guided you on how to do the crushing, especially for this example. We are now going to move to the last stage where we consider to do what? To revise the network diagram. So the question you'll be asking, you network, then activity A, did I crush it? Yes or no? By how long? What is the remaining amount of time? You indicate it on the network diagram. Activity B, was it crushed? Yes or no? Then again, you indicate the amount of time in your network diagram. After which, we have the end of our required as per that example. Because our process of crushing, once it is over, you move to the stage of doing the time cost analysis. And the last thing that you should have is to consider revising your network diagram. So that is the exercise for today. You remember to network again. After you have considered the activities which have been crushed, make sure you indicate the remaining amount of time. And lastly, in your network diagram, one should be able to see that these two parts, BFH and ACG, are emerging to be critical path in the project. So that was our example. We are saying this is December 2014 from our past papers. The question was question 3C. So we mark the end of our session for now. In our next session, we are going to look at the Gantt charts. Thank you for your attention.